Hello everyone. Today we'll be talking about graph transformations in precalculus, mainly comparing shrinking and stretching of a graph. So, let's say we have a parent graph, y equals to x squared. It's going to look something like this. Alright, so shrinking is basically when the x's are increasing way quicker than the y's. Sorry, that's stretching. And shrinking, on the other hand, is when the y's are increasing way faster than the x's. So how does this happen? How do we have faster increasing y's or faster increasing x's? It all depends on the coefficient next to x. So in shrinking, the coefficient has to be greater than 1. For example, y equals to 3x squared. Let's have a bunch of points, x, y. Stretching, the coefficient has to be less than 1. For example, y equals to 1 over 4 x squared. In this case, let's compare the data points between both cases and between the parent graph. In the parent graph, our main points are going to be, let's see, negative 1 squared, 1, 0, 1, I'm sorry, 0, 0, 1, 1, 2, 4, and 3, 9. Those are our main points. Now let's see what happens if we shrink them. Let's multiply this by negative 3. Negative 1 squared times 3, that's 3. So we're going to have 3. The x's are not changing when we're adding coefficients, it's just the y's that are changing. 0 squared times 3, that's going to be 0. 1 squared times 3, 3. 2 squared times 3, that's 12. And 3 squared times 3 is 27. So as you can see, our y's, the x's don't change. Our y's are much faster, much bigger. 4 compared to 12, 9 compared to 27. Therefore, our graph is going to look like this. At a point like 3, we're going to have 27. On the other hand, when we have stretching, since the x's don't change, only changing the y's, so at negative 1, we're going to have 1 over 4. 0 is going to be 0, 1 over 4. And at 2, 2 squared is 4 times 1 over 4, that's 1. 3 squared, that's 9 over 4. So on the graph, this explains the slow progression of y and the quick progression of x. As you can see, at a point such as 3, the y is going to be just 9 over 4, which is just more than 2, compared to in the parent function when it's supposed to be at 9. Therefore, the progression of x is much slower. So the points to remember are coefficient here is less than 1, here it's greater than 1, here the x grows much faster than the y, here the y grows much faster than the x. And the explanation is all here. And that's it. Thank you for watching.